Have you ever heard the term hero engineering? It sounds cool, right? Like something out of a comic book.
It's this idea that one brilliant person, a lone genius, can swoop in and solve a massive, complex engineering problem all by themselves. We see it in movies all the time. Think Tony Stark building the Iron Man suit in a cave with a box of scraps. It's a compelling narrative, a story of individual triumph against impossible odds.
But here's the thing. In the real world of engineering, it's almost entirely a myth. Today, we're going to dismantle this myth of the lone hero engineer.
We'll explore why this idea is so persistent, why it's actually harmful, and what the reality of modern engineering truly looks like. Stick around, because understanding this is crucial not just for aspiring engineers, but for anyone who wants to grasp how the incredible technology shaping our world actually comes to be.
Let's start with where this myth comes from. Our culture loves stories about heroes.
From ancient legends of Hercules to modern superheroes, the narrative of a single, extraordinary individual changing the world is deeply ingrained in our storytelling. And when it comes to science and technology, we do the same thing. We talk about Isaac Newton and the apple, Albert Einstein and his thought experiments, or Steve Jobs revolutionizing personal computing from his garage. These stories are inspiring, no doubt. They simplify complex histories into easily digestible tales of genius.
The problem is, they're incomplete. Newton built his work on centuries of astronomical and mathematical observation.
Einstein was in constant dialogue with his contemporaries, hashing out the mind-bending implications of relativity. And Apple's success was the result of a massive team of engineers, designers, and marketers, not just one man in a turtleneck. The media amplifies this by focusing on the charismatic CEO or the lead inventor, turning them into the public face of a huge collaborative effort. It makes for a better story, but it's a distortion of reality.
So, why is this myth of the hero engineer actually dangerous?
Well, for starters, it creates completely unrealistic expectations. If you're a young engineer just starting out, and you believe that real engineering means having a eureka moment and single-handedly building a world-changing device, you're setting yourself up for disappointment and burnout. You might feel like a failure when you spend your days in meetings, debugging someone else's code, or running endless simulations. You might think, this isn't what I signed up for. I'm not a hero.
This mindset can lead to serious imposter syndrome. You look at the titans of the industry, the heroes celebrated in magazines,
and you compare their perceived accomplishments to your own daily grind. The gap can feel immense and demoralizing. But the truth is, their daily grind probably looked a lot like yours. The final, polished product is all we see, not the thousands of hours of tedious, collaborative, and often frustrating work that went into it.
Furthermore, the hero myth actively discourages the very thing that makes modern engineering possible: teamwork.
When individuals are obsessed with being the hero, they're less likely to ask for help, less willing to share credit, and more prone to hoarding information. This creates a toxic work environment. Imagine a team where everyone is trying to be the star player instead of passing the ball. You don't win championships that way, and you certainly don't build a space telescope or a global internet infrastructure.
Ego gets in the way of progress. An engineer who thinks they have all the answers won't listen to a junior team member who might have spotted a critical flaw.
A department that sees itself as the hero of the company might refuse to collaborate with other departments, leading to siloed information and duplicated effort. This hero complex breeds conflict and inefficiency, which are the enemies of good engineering.
So, if hero engineering is a myth, what's the reality?
The reality is something I like to call team-based, systematic engineering. It might not sound as glamorous, but it's infinitely more powerful.
Let's break that down. First, team-based.
Modern engineering problems are almost always too complex for one person to handle. Think about designing a new smartphone. You need electrical engineers for the circuitry, software engineers for the operating system, material scientists for the screen, and casing, mechanical engineers for the physical design, and radio frequency engineers for the antennas. And that's just a small fraction of the team. Each person is a specialist, a deep expert in their own domain. The magic happens when these experts come together, communicate effectively, and integrate their work into a cohesive whole.
The real heroes of engineering are often the project managers, the systems engineers, and the great communicators who can bridge the gaps between these different disciplines.
They are the ones who ensure that the software team's code will actually work with the hardware team's new processor. They are the conductors of the orchestra, making sure every instrument plays in harmony. Their work isn't always visible, but it's absolutely essential.
Next, let's talk about systematic. Real engineering isn't about wild flashes of inspiration. It's a disciplined, methodical process.
It involves rigorous planning, detailed documentation, extensive testing, and iterative refinement. We use methodologies like Agile or Waterfall project management. We have design reviews where peers scrutinize every decision. We have quality assurance teams dedicated to finding bugs and weaknesses. We write test cases, we build prototypes, we analyze data.
This systematic approach is what allows us to build incredibly reliable and complex systems.
Think about the software that runs an airplane's fly-by-wire system or a nation's power grid. You don't want that to be the product of one person's brilliant idea that they coded up over a weekend. You want it to be the product of a slow, careful, and systematic process involving hundreds of people, with checks and balances at every single step. This process is designed to catch human error, to account for unforeseen circumstances, and to build robustness into the very core of the system. It's the opposite of the lone hero's reckless genius.
Let's take a concrete example: the James Webb Space Telescope.
This is one of the most incredible engineering feats in human history. Did one person design and build it? Of course not. It was an international collaboration involving thousands of engineers, scientists, and technicians from NASA, the European Space Agency, and the Canadian Space Agency, spanning over 2 decades. There were mirror specialists who had to figure out how to create perfectly smooth, foldable, gold-coated beryllium segments. There were cryogenics experts who designed a sun shield the size of a tennis court to cool the instruments to near absolute zero. There were software engineers who wrote millions of lines of code to control its deployment and operation, a million miles from Earth.
If any one of those teams had failed, the entire project would have failed.
If anyone had tried to be a hero and go off on their own, they could have jeopardized the entire multi-billion-dollar mission. The success of the James Webb Telescope is the ultimate testament to team-based, systematic engineering. It's a triumph of collaboration, communication, and painstaking, methodical work. There are no lone heroes here. There are thousands of dedicated professionals, each contributing their vital piece to an unbelievably complex puzzle.
So, what should we do? We need to change the narrative.
For those in leadership positions, it means celebrating the team, not just the individual. When a project succeeds, praise the entire group. Highlight the collaboration that made it possible. Create reward systems that incentivize teamwork and knowledge sharing, not individual glory.
For educators, it means teaching engineering as a team sport from day one.
Group projects shouldn't be a chore. They should be the core of the curriculum. Students need to learn how to communicate technical ideas, how to resolve conflicts, and how to integrate their work with others. These soft skills are not soft at all. In the real world, they are every bit as important as technical prowess.
And for all of us, especially aspiring engineers, it means embracing a new kind of role model.
Instead of idolizing the mythical lone genius, let's look up to the great collaborators, the humble leaders, the patient mentors, and the diligent testers. These are the people who make modern technology happen. The goal isn't to be the hero who saves the day single-handedly. The goal is to be a valuable, reliable, and collaborative member of a team that, together, can achieve something extraordinary.
The myth of hero engineering is a simple, attractive story.
But the reality of collaborative engineering is far more powerful and, I think, far more inspiring. It's a story about how ordinary people, by working together with discipline and mutual respect, can accomplish truly heroic things. It proves that the whole is, and always will be, greater than the sum of its parts.
Thanks for watching.
If you found this perspective on engineering interesting, hit that like button and subscribe for more content that goes beyond the headlines. And I'd love to hear your thoughts in the comments. Have you ever encountered the hero engineer in your work or studies? Let's talk about it. See you in the next one.